Hello guys, I'm a teacher in Masame. Let us take a look on the question below. We have a questions from TIE 2022, book 4, concept of waves, and this particularly a sound wave. This question is original from A.F. Abbott, that is 1989, physics. That's the exercise 27, question number 9. We have given two men that are standing facing each other, that are separated by distance 200 meters. One on one side of the high wall, and at the same perpendicular distance from it. Let us deal first for this information until this comma. Okay, we have two men as they've given. These two men separated by distance which is 200 meters between them, and these two men they have at the same perpendicular distance from the high wall. This is the high wall. This is our high wall, and these two men are from the same perpendicular distance from the high walls. And this one holds the pistol, and this one raise his hands up in a perpendicular distance. Then when one fires a pistol, the other hears the reports 0.6 second, and as one fires the pistols, the one who raised his hands up here reports at 0.6 seconds. Okay, and this same man will hear the second reports after the interval of 0.25 seconds after the first. Now, from the concept of reflections of sound waves, what result into an echo, this other man will receive an echo as a time interval of as the sum of time interval of plus the time 1, in which the total time we assign it as a time t2. Hence, this time t2 is equal to the first time for the first report plus the interval, and we will have 0.85 seconds. Now, once incident wave and the reflected wave will have a total time of 0.85 seconds. Now, the time for the incidence will be the half of, and the time for the reflection will be the half of the total times t2. Now, let us take a look on definition for the terms to be used. This is time 1, this is time 2 for incidence, time 2 for reflections, time for S. This time for S is perpendicular distance. We know that from law of reflections, the incidence angle is equal to reflected angles, and the normal lines here is our perpendicular distance from between these two mains from the high walls. And this perpendicular distance from C to A is the same as this one from the ground. Okay, and we have this hypotenuse which is as T2 Rs, and this adjacent as T2S, and this time for opposite is for T1 half. And we can use time, and also we can use distance or displacement to calculate the perpendicular distance that is assigned by letter capital S. Okay, how to calculate the velocity of sound in air? Now you can find the velocity of sound in air by taking this distance d as divided by the time taken for a sound to be heard by this other man as a first report. Then you have 33 meters per second approximate, or 333.33 meters per second. Okay, by applying Pythagoras theorems, we'll be able to find the time for displacement S. We know that this time will not be the same as time for hypotenuse as for the wave which travel in the same medias. We know that with the same parameters, we know that the time will not be the same for adjacent and for hypotenuse, even respective for the opposite. Okay, now our time ts will be equal to as you can see here, and we multiply with velocity so that we'll get a displacement s. and then our distance, perpendicular distance from this mains to the wall is 100.35 meter or 100 meter for approximated one, and for what is not approximated. And if other methods, you can use displacement SR for reflections, displacement at hypotenuse. Then we multiply with velocity of sound, which is the same. Then we multiply with time for reflections of the sound wave. Then we will have a hypotenuse distance, this distance from CA to B. Then we are supposed to find AC, while the CB is equal to a distance D we divide by 2, which is equal to 100 meter. Then from Pythagoras theorem, our AC will be equal as 100.345 meter per second, or 100 meter, not meter per second, because this is displacement, sorry, not meter per second, just a meter, and this is just a meter. Okay, thanks for watching. Please like, share, comment. Don't forget to subscribe for more videos like this one.